Hi, and welcome to Caveman Digital. In this video I'll be walking you through how I created some of the fine scale pipework used for my HO scale scratch built Shay Class C 70-ton locomotive. These models are built with Fusion 360 and relatively straightforward, but are using some great features from Fusion 360, and although I've always used Maya in the past, Fusion 360 has become my go-to tool as I find it a lot quicker to get good simple results that I can easily print, and hopefully that is something I can show here as well. Throughout the project, I'll be keeping in mind the minimum parameters that the printers require, the main one being a 50 micron wall thickness for freestanding walls. This will make sure that all the details put in are visible once printed. At about 8 minutes in, you can see the flange pipe printed, and at the end of the video there are photos of the valved pipes. Let's get started with the flanged pipe. We start with a simple line of 3 mm, to which we add another perpendicular line of 3 mm as well. We then apply a fillet to that line to give us a really nice way to control the curve to turn this into an elbow joint. This will be our path. We then create a simple circle of 2.4 mm diameter. Dimensioning, by the way, can be done by hitting the D key in Fusion 360. This will be our profile. We then use a sweep to create the elbow joint, and that is the first step done. We add a flange to this object, which we can detail with some bolts later on. I used 2.8 mm for this. You can either create a new circle in our existing sketch as seen here, or as shown later on, you just create a cylinder of the profile of the pipe itself. The thickness of this flange needs to be 0.5 mm in order for it to be printable, but going 0.5 mm in was a bit too much, and going 0.5 mm out I found too much as well. This is mostly aesthetics though, of what I think would look good at such a small scale, so I opted for extruding out and a bit in until I got my 0.5 mm, and I do the same on the other side. Then come the bolts. I created 0.2 mm by 0.2 mm square on the back of the flange. Doing it here on the back means I can actually center it nicely between the outer and the inner edges, so I do not have to move it around, which could happen if I do it on the other side, where it might be harder to actually see where the two borders are for the top and the bottom. I chamfer the edges of the cube to turn it into a hex nut, making it 0.1 mm high, which is the minimum height required for the details to show up when printing. Using a circular pattern, I then duplicate that on the other side and replicate that process 2 more times for the other side of the pipe. And that's it, we have a 2 mm flanged elbow pipe piece that can be printed. I repeated a similar process for an elbow joint. There's 1 mm and another one that's 0.5 mm in diameter. With the 0.5 mm, the actual flange itself is so small that it's considered detail rather than wall. It's only 0.1 mm standing off the pipe itself, meaning that I can go a lot thinner on the edge to make it look proportionate to the actual diameter. I duplicated this model a few times and connected it with sprues so I can have multiple of them printed in a single print. I ordered a bunch from Shapeways, but I was curious how a Formlabs printer would perform on this as well. Shapeways is great, but sometimes you just want things quicker, so I turned to 3D Labs, and someone here in Montreal had a Form 1 Plus who was willing to give these tiny designs a shot, and they came out beautifully. They were printed at 25 microns and it took a couple of hours to print, but even on the 0.5mm diameter, as you can see in these photos, you can actually see the tiny bolts, which is just amazing, and I can't wait to get these actually built into the locomotive itself. My Shapeways prints are on the way now as well, but getting these prints from the Form 1 Plus are just amazing. I wasn't actually really expecting that level of detail to come out of a desktop printer you could have at home. Next, we're gonna look at the valve pipe. For the valve pipe, we start with a simple cylinder. We add 2 cubes on each side and use the same chamfer trick that we did earlier on to turn that into a hexagonal shape. We add a cylinder to that and to make the base for the valve. We build a cube onto that and chamfer it as well, followed by another cylinder and another cube that is also turned into a hex nut. To then create the cylinder for the valve handle itself, here again we have to keep the 0.5mm thickness in mind for the handle, but for this first 2mm pipe valve this is not a problem. We even make it slightly thicker. In the photos later on you can actually see a pipe valve that has a diameter of 1mm and the actual handle in there is 0.6mm diameter as well. I didn't bother making a 0.5mm diameter valve just because it would have been so small, that the details would not be visible and it was just not worth modeling or trying to print. And now actually comes a really interesting part I find, and it's making a curved profile. We start by creating the shape we want, the bar that connects the valve handle to the valve itself. This is done from the top view and it is a flat design. We then turn on the side profile, create a curve that has the right shape. I started with just a simple straight edge, but a more curved profile is shown a bit later. We then go into patch mode. Patch mode, unlike the model view in Fusion 360, does allow single edges to be extruded. Patches do not require a thickness, where anything done in the modeling view does. So we extrude the line wide enough so that it passes underneath and beyond the shape we drew earlier on in our top view. We then do an intersect between both objects, and this gives us a curved angled plane. To then turn this into a model that we can use again later on with just modeling tools, we use a thicken in the patch menu. And that way we have an object that we can now actually use in both the modeling and the patch view. As I said, the first one was just a straight line and I wasn't too happy with it, so going back into the modeling history, I adjusted the line and made it slightly curved. Fusion then automatically recalculates everything, which makes things a lot easier when you want to make tiny tweaks. Similar before, I duplicated this and made a few variations. No valve, no hex nuts, etc. and attached them with sprues and got these printed as well. And they came out absolutely amazing. The valve, I find, is absolutely perfect. The details are visible with the naked eye on the 2mm valve. A bit harder to see on the 1mm one, but the details are definitely there. I had a look at them with a loupe and just everything that I modeled is there. It's just amazing. Getting them detached from the sprues was slightly tricky, as things are pretty fragile and the sprues, when snapped with pliers, can exercise a fair amount of stress on the parts, so I got a really sharp X-Acto blade and slowly cut through them. This allowed me to get them detached. I will be drilling into these with a small drill, and actually what I'll be doing is using half the size of diameter. So for the 2mm one, I'll be using a 1mm drill, and I'll be inserting a pipe of 1mm and then sliding a pipe of 2mm over top of that. And I use the 1mm pipe to actually attach the 2mm one. But I'll be showing this in a disassembly in a different video, so stay tuned for that. This brings us to the end of this small tutorial. I hope it was useful. If it was, please give it a thumbs up. Or otherwise, let me know in the comments below how I can improve this. This is my first tutorial video on YouTube, so any sort of recommendation is highly appreciated. And thank you for watching, and I'll see you soon.